Hello everyone, this is graduate chemistry. Today we will study catalytic hydrogenation. Okay, today we will discuss the reduction. Okay, this is reduction. Today we will discuss reduction, and we can define reduction reaction by many ways. From our childhood, we have studied about reduction, and oxidation. From our childhood, we have studied about both the oxidation and reduction, and we have defined this oxidation and reduction by many way. And another way, in the very simplest way to describe the reduction, is addition of hydrogen to any unsaturated group is named as reduction reaction. Okay, so we can define it very simplest way, that is the addition of hydrogen to an unsaturated group. From in organic chemistry perspective, we can our definition is almost correct, and now we will see the examples. Our first example is reduction of alkane. Second one is reduction of ketone. Here the reduction of alkyl halide, that is the alkyl chloride, is happened. Here the reduction of thiol is happened. All these kind of reaction are called reduction reaction. And reduction is a kind of reaction which we use and which may be much useful in organic synthesis, many step in organic synthesis reaction. So reduction can perform by two way. Reduction reaction can be performed by two way. First one is catalytic hydrogenation, and second one is by reducing agent. Okay, so what is first one? That is the catalytic hydrogenation, and second one is by reducing agent. What is catalytic hydrogenation? That is we use the one catalyst and hydrogen gas atmosphere, and we use the catalyst. And we put our substrate, and then we keep it in hydrogen gas atmosphere. Then the substrate will convert to product, that is hydrogenated product, and this procedure is named as or referred as catalytic hydrogenation. And second step is what? Second step, this is the another procedure, is reducing agent, by reducing agent. So there is various kind of reducing agent, that is sodium borohydride, lithium borohydride, this is the lithium aluminum hydride. All these are reducing agent. So by this kind of reducing agent, we can also reduce the alkane. So today we will study about catalytic hydrogenation, and in the next video we will study about the reduction by reducing agent. That is the NaBH4, lithium borohydride, lithium aluminum hydride, or there are also others reducing agent also present there. So there are various catalysts in reduction reaction. We can use various catalysts. What kind of thing we can use as a catalyst? That is the finely divided metal is one thing which we can use as catalyst, and another thing is metal oxide. What kind of metals we generally use? Palladium, platinum, etc. This kind of thing we use as a catalyst. And many cases we use platinum oxide as a metal catalyst. Okay, as a catalyst. So this is metal oxide kind of catalyst. So first example first example what we will study today is Adam catalyst. So what is Adam catalyst? Adam catalyst is platinum oxide. Okay, platinum oxide is referred as Adam catalyst, and it is used in hydrogenation reaction. So we take our substrate, we put the catalyst in our reaction vessel, and we maintain the hydrogen atmosphere, and that's what we can convert the substrate into our product. So first one is Adam catalyst, which is discovered by Roger Adam. And before Roger Adam, the reduction is done by palladium or platinum black. Before Roger Adam, it is done by palladium or platinum black. And what was the drawback behind it? That is the isolation of product. Isolation of product was the drawback at that time, that when we use the platinum or palladium black as a catalyst, the isolation of product is difficult. But we can convert by using this kind of catalyst. We can convert this into product, but isolation of product is very difficult by using this palladium or platinum black type of catalyst. So scientist Roger Adam, he found the solution, and that is platinum oxide, and that is referred as Adam catalyst, and it is prepared from chloroplatinic acid H2PtCl6. And actually what happened, platinum oxide here, the reducing, this is the catalyst. Okay, and we use hydrogen H2. Okay, then what happened, in presence of hydrogen, it is reduced to platinum, and this is the actual reducing agent. The reducing agent. The platinum oxide is not the reducing agent. In situ, platinum is formed by the hydrogenation of platinum oxide, and that is the reducing agent. Here, to reduce the alkene to alkane. Okay, so next, yes. This is the first one example of Adam catalyst, the reduction by Adam catalyst. It is the first example, and another thing is that it can also reduce nitro group to NH2 group. It has power to, it can reduce the NO2 group to NH2 group. And in presence of, another important thing is that, this is very important thing, that is in presence of NO2 group, it can reduce olefinic system. Let's say consider this system. Okay, this system, and you put the Adam catalyst here, then your product is what this is. So this part will reduce, and this part will reduce, but this is not. And this is as it is present, that is present as NO2. Okay, So this is very important, that in presence of NO2 it can reduce NO2, but in presence of olefin and NO2 it can selectively reduce the NO2. And if you use the high pressure or high temperature kind of thing, then it also reduce the NO2 and NH2 group, but generally in presence of NO2 it can reduce only this part, only this olefinic part. Okay. And another except Adam catalyst, we can use hydrogen palladium carbon as a catalyst. This is one example. Hydrogen nickel with pressure and temperature, high pressure 100 atm and temperature is 50 degree, it can also use as a catalyst. Another is Raney nickel. It is also a reducing agent. It can also use in catalytic hydrogenation. Reduction in aromatic ring. Here what happened, the aromatic ring, that is the benzene ring is reduced here by platinum oxide catalyst in presence of acetic acid. Here is solvent, and hydrogen gas is used as it is reduction reaction. So here what happened, the reduction of aromatic ring happened. So here is a list, that is when the by presence of what catalyst, the which group will reduce. Okay, so in presence of palladium catalyst, it can reduce CBZ, that is the benzyl group, CBZ group. It can reduce CBZ, and it can also reduce the ether can also reduce the ether. And in presence of platinum nickel, it can reduce the alkane. And for reducing the aromatic ring, reducing platinum or rhodium catalyst, or nickel under high pressure, it can reduce the aromatic ring. Okay, next is Rosenbaum reaction. This is the reduction of acyl chloride. What happened, here the platinum barium sulfate is used, and hydrogen gas is used. So palladium barium sulfate is used. Here palladium is the catalyst, and barium sulfate is has a specific rule, but I forgot it. Okay, I will tell in the next part of the video. And next is linear catalyst. Okay, so what is linear catalyst? It is palladium, calcium carbonate, and lead acetate. That is linear catalyst. And what is its utility? It can reduce the alkyne to alkene only. Alkyne to alkene to alkene to alkene. Okay, so it can stop here. It can stop this reduction thing here. And after reducing further after using further reducing agent, it can reduce the alkene. Okay, so it will stop here. Okay, this is the utility of that linear catalyst. Next, so this chart is very important, that is the which substrate can reduce what. Okay, so aromatic ring, for reducing aromatic ring, is there is question there you will find the questions in various type of exam, that they use the platinum or rhodium catalyst under high pressure, and if you forgot that, you can't you keep the aromatic ring as it is, but it is actually not the case. It will reduce in presence of platinum or rhodium catalyst. Okay, so next Next is very important. Next thing is very important. This is this is one olefin. Okay, generally catalytic hydrogenation after catalytic hydrogenation we get cis product. Generally we get cis product by catalytic hydrogenation, but sometimes it's happen we get trans product too. So here is the example, and it is very important that if we use the hydrogen platinum oxide as a catalyst, then we get cis as a measure, and if we use the palladium, then we get trans as a major product. Trans is major. This is trans is major, and here cis is major. But and why this thing happen? Why this thing happen? The explanation is that in case of in the step of reduction, that this alkane is reduced. Okay, this alkane is reduced, and we know the reaction is reversible. So this alkane is reduced, this double bond is reduced, and it can after reduction it can shift in here or here. Okay, and from which phase this reduction happen? It can happen, the reduction of the shifted double bond can happen from different side. That's why we get the trans product as a measure. So what happened in presence of palladium catalyst, the after reduction of this bond, it can shifted this part, and this can reduce this thing is reduced from the other side where it is happen, where this reduction is happen, it can happen from the other side, and by this way we get the trans as a measure, but here cis as a measure product. Same thing is that this is the substrate. Okay, this is the substrate, and we use hydrogen palladium, and this is the solvent. Okay, so here we get cis and trans, and when cis is measure, when trans is measure, if R group is substrate dependent, if R group is cis2H, that is this is, then the cis is measure, cis product is measure. Or if R group is CO2Me, then trans is measure, trans is measure. Okay, and why this is happen? Because in presence of CO2Me, the double bond can shift, and the reduction can happen from another side of the another phase. Reduction can happen from the another phase. The shifted double bond is reduced from the another phase. So the trans product, we can obtain the trans product. Okay, so in presence of CO2Me, it become more flexible. The ring become more flexible. Okay, so here the trans become the major product. And lastly, can discuss one thing, that is the if any oxygen or nitrogen group is present in benzylic position, then we can use an interesting catalyst, that is the rhodium aluminum oxide, and which can reduce our benzene ring, only if the NH2 or OH group is present, then only this thing happen. Always this thing is not happen only if the NH2 or OH group is present in the benzylic position, then only if we use the rhodium aluminum oxide as a catalyst, then it's reduced. Okay, so this up to catalytic hydrogenation, and after next video we will discuss the some remaining part of catalytic hydrogenation, and the then we will move on to the reduction by reducing agent, and here we will found the chemoselectivity and different selective reducing agent. Okay, so fine.